Here is your Unit 2 Scale Factor and Dilation quiz review. For number 1, you're going to dilate A using center of dilation P by a scale factor of 4. So looking at the circular grid, I need to find point A, and I can see here that point A is 1 block away from the center P. So since A is 1 block away, and the scale factor is 4, I'm going to do 1 times 4, which is 4. So that means I'm going to move A 4 spaces away from the center. So when I go to the circular grid, I'm going to go 4 spaces away from the center. 1, 2, 3, 4. And A prime will land right here. Moving on to number 2, I'm going to dilate B using the center of dilation P by a scale factor of 1/2. So it's going to become half the distance. So let's look at B. Right now, I can see that B is 2 blocks or units away from the center. So I have to do 2 times 1/2, or half the distance. 2 times 1/2 is 1. So I'm going to go 1 block away from the center, right here, and I'm going to label that B prime. For number 3, we're going to dilate the following polygon with a scale factor of 1/2. And the center is the origin. List the coordinates for the image and the pre-image, and then graph it. Okay, so let's first list all of our coordinates of the image that is there. So beginning with A, you can see that A is forward 4 and down 2. So A, the ordered pairs for A is 4 and -2. B, you can see B goes back 2, down 2. So B is -2, -2. And then C is back 2, up 2. So C is -2 and +2. Now, since the scale factor is 1/2, there's a couple ways to think about this. You can multiply every number by 1/2. For example, 4 times 1/2, that's our first coordinate right here, 4. So 4 times 1/2, if I multiply fractions, I'm going to make them both fractions, and then I just go across the numerator and the denominator. So I get 4/2, and 4 divided by 2 is 2. I also like to think of it as just taking half of that number. What is half of 4? It's 2. So that's another way you could think about it. Or multiplying by 1/2 is the same thing as dividing by 2. So if I did 4 divided by 2, I would also get 2. So a couple different ways to think about it. For me, the easiest way is just to take half of everything. So 4 times 1/2 is 2. The next spot up here is -2. -2 times 1/2 is -1, just half of that. And then here, the next ordered pair is a bunch of -2's. So half of -2 is -1, and -1, and then -1, and then +1. Okay, so I just took half of every single digit there. Now we graph it. Okay, so I'm going to go forward 2, up 1, and that is going to be, oops, sorry, that's wrong. Forward 2 and down 1, that's going to be A prime. And then I'm going to go back 1, that's going to be B prime. And -1, +1, and that's going to be C prime. And then I'm going to connect it, and we should have a similar figure, the same shape, just a smaller size. It's going to be half the size. Now I can check that we did it right by looking at a couple of things here. So I could look at the original image, and I can see that it was 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 units long on the base of that triangle, and half of 6 is 3, 1, 2, 3, and that became 3 units long. So that kind of checks out. And then with the height of this triangle, 1, 2, 3, 4, it's 4 units long, so half of that would be 2 units long. So those dimensions check out as well. Also, all the angles would be the same. So if I took some patty paper and checked out all the angles, you can see I have a right angle inside here, and I have a right angle right here, and then these other angles would all match up as well. All right, so there we go. Okay, next we're going to dilate the rectangle A, B, C, and D using center P and the same scale factor. We're going to do half the distance. Okay, so this time we don't have any units, any numbers on our graph, so we have to count from the center P. So count from this middle point right here. Okay, and we're going to go half the distance. So I'm going to start with A. So A, I go 1, 2, 3, back 4, and down 2. So back 4 and down 2. So I need to go half the distance. So that means I go back 2 and down 1. I just cut those in half. And that's where A prime is going to be. Okay, so I'm going to go back 2 and down 1. So right here is where A prime would be. Okay, so everything is based off that center. All right, so next I'm going to do B. So B is also back 4, but it goes up 2. So it's the same thing. I'm going to go back 2, but now go up 1 for B prime. Moving on to C. C is 1, 2, 3, forward 4 and up 2. So kind of getting a little pattern here. So C will go right here, C prime. And then it looks like D is forward 4 and down 2. So D is going to end up being right here, D prime. Okay, so it shrunk down. It's half the size. And then again, I'm going to do those couple of things where I check it. Like the length of this is 1, 2, 3, 4, 5, 6, 7, 8 blocks long. So if I did half of that, this should be 4 blocks, and it is. And then the height, the original height is 1, 2, 3, 4 blocks. So this height should be half that, which is 2 blocks. So that checks out, and then they're all right angles. Okay, so now we are given polygon ABCD is being dilated by a scale factor, and the center is 0, 0, the origin. And it creates this green image. So you can see that it went big to small. So that means it reduced. So that means our scale factor has to be less than 1. Okay, so a couple different ways I can do this one. I might just focus on A and A prime and then see what happened, how the numbers changed. So let's do that. Let's look at A. Okay, and I can see that A, the original A is -4 and +4. And then A prime is -2 and +2. So, okay, that's kind of easy to see. They cut in half. So our scale factor is a half. Now, just to be sure, I'm going to select another point and just make sure like that works for that point as well. So let's go on to B and check B and B prime. So B is 0, -2, and B prime is 0, -1. So that works out. Those are also cut in half. So I might as well keep going and check C. And I can see that C is at 4, 0, and then C prime is at 2, 0. Again, that looks like it cut in half because you can't take half of 0. And then letter D, I'm sorry, D is 8, 4. So if I cut that in half, D prime is probably at 4, 2, and yes, it is. Okay, so we had it in the beginning. It is cut in half. We can also kind of visually see that it's half the distance or half the size of the original. Okay, so we are asked to name 2 things that are always true about a dilation. So thinking about that, dilation, one thing for sure that's always true is the shape is always the same. So we have the same shape. But the second part of it is the size is not necessarily the same. So I wanted to add something about that. So it's the same shape, but not necessarily the same size. So it could enlarge, it could reduce, or it could be the same size if the scale factor is 1. Okay, so that's one important thing about the shape. And then the second thing that I think is super important is that the angles are always the same. So sometimes people will say the angle measures are preserved. The angle measures inside the shape are always preserved or stay the same or congruent. So the sides might change by the scale factor, the side lengths of the figure, but the angles inside will always stay the same. The angles are always congruent. Okay.